Okay, let's continue with some definitions and examples in this class of logic. The first thing that I want to remark to you is what is a satisfiable formula? Well, the satisfiable formula, in my way to understand this, is that no matters how we substitute the zeros and the ones or the false and true values, we always get one or true. Let's get start with some example to understand better this. An example, if we have one formula here, negation P, and disjunction P, that means that is a valid formula in the way that if we put an example 0, 0, and then 0 and 0, it will be 1, and if we put 1 and 1, the result it will be 1 here. If we put the negation, obviously it's 1 and 0. In the middle we have the result of true. So that is a valid formula, and this is remarkable. Okay, when is a satisfiable formula? That at least one value, here, one value is 1. And the difference between equivalent formula, that in one row we have just at least 1, in equivalent formula, the equivalent formula, all the elements of the rows must be exactly the same. Let's make one example with A and B. In the A, I'm going to put this formula, negation P, conjunction Q, and we're going to put another example, which is negation P, implication P, I'm sorry, is negation Q, implication P. And let's make one truth table just to figure it out, how is this going. If we put here the P and the Q, let's start with the true value. If here is 0, also here's going to be the 0. We can repeat the 0 here, but here is going to be twisted, mixed, so here is going to be 1. And also we can put the 1 and 0 and 1 and 1. Here are all the possible answers. Let's make one line to separate this, and let's start over. If we put here the values of the Q, we can start by saying that in the Q we are going to repeat this line. So this is 0, 1, 0, 1. In the side of P, we are going just to repeat the same. So it's going to be 0, 0, and 1 and 1. The implication is going to be, the only chance that is going to be one implication is in 0, is when we have a true and then we get a false. So in this case we got, and I'm going to put in with another color here, the 0. Otherwise is going to be 1. So the negation of this is going to be our last result. I'm going to put here in color, and the result is going to be the negation of this is 0, the negation of 0 is 1, the negation of 1 is 0, and the negation of 1 is 0. This is our final result, and the way that we are going to compare with this formula to check if this is equivalent formulae. So let's start over with this example. We are going to copy 0, 1, 0, 1. the negation of P is going to be the negation of this value, okay? So we are going to negate this, and this case is 1, 1, 0, 0. And with another color, we're going to suppose that the only way that is going to be true is when they are the same. So 1 and 1 or true and true is give you 1. Otherwise, it's going to be false or 0. So this here is exactly the same in all the rows element. 0 and 0 here are the same. 1 and 1 here is going to be the same. 0, 0 is the same. 0 and 0 is the same. So that means this is equivalent. This and this formula are equivalent formulae. Now, what is well, we have this, and what is a logical consequences? We suppose that one formula is A, an example A, and another formula is B. So let's make one simple example to make sure that we can understand the logical consequences. A is a logical consequences of B, and wherever B is 1, then A is 1 too. An example, we can suppose that P equivalence P disjunction Q is going to be the logical consequences of P disjunction negation Q. How come this is going to be? Let's make a one truth table. In this truth table, we're going to put P and Q. Let's separate this with the value. Remember, here's you start with a 0, 1, 0, 1, and here is 0, 0, and 1, 1. Because there are just two elements, and here are all the possible answers. So this is going to be the logical consequences of P equivalence this P disjunction Q. So here making the table, we are going to check that if we put this another formula, P disjunction negation Q is going to be the logical consequences, and in a specific this line. If we make the calculus according with this is the number 1, but also in the last element, which is here, we are going to get the true value or 1. Here we don't care because this always get 0 in this line. This line is our really important guide that we want to check. So the another way here is going to be 0, and here we are going with another 0, so here we don't care, but here we get the number 1, and here also we get the number 1. Also here we get the number 1, and here also with the number 1. So this is equivalent formula. So we say that if we put this formula A and this formula and B, we say that A is the logical consequences, this row is the logical consequences of B, and B is the logical consequences of A. That means these results are the same. Remember that the final answers is going to place here and must to be equal or have the true values in the same row. if this row is not to be the same like here, that is not a logical consequences, because just with one element different is not a logical consequences. But here we have exactly the same in the same rows. So this is the end of this result. We are going to make the same exercise in the next video. Okay, so thank you for watching. Please subscribe, and if you have any questions or if you want to give me a feedback, please uh, don't instant to do it.